Number 10, the Carrington event. September 1859. Telegraph operators across 2 continents watched their equipment catch fire without being plugged into anything. Sparks leap from metal wires. Paper ignites on desks. In the night sky, auroras burn so bright over Cuba and Hawaii that people wake up thinking the sun has risen early. This is the day the sun reached out and touched the earth directly. The storm that struck in 1859 was the strongest solar event ever recorded. A wave of charged particles slammed into the planet's magnetic field, and the only infrastructure sensitive enough to notice was a fragile web of telegraph wires. Even so, entire networks failed across North America and Europe. Operators reported receiving messages even after disconnecting their batteries, as if the sky itself had become the power source. Now imagine that same storm arriving into a world built entirely on invisible currents, where every home, every hospital, every water system depends on a grid nobody in 1859 could have imagined. Because that is what would happen today. The same intensity of solar storm hitting modern Earth would not just knock out telegraph lines, it would surge through every transformer on every power grid on the planet simultaneously. Within hours, satellites would lose navigation and communication function. Within a day, transformers designed to run for decades would begin to melt from the inside. And these are not parts you can order overnight. They take months to manufacture and ship. The scale of what follows is almost impossible to hold in your head. Estimates suggest a Carrington-level event today could leave over 130 million people without power in the United States alone, for months, not days. Food refrigeration fails within hours. Water treatment plants dependent on electric pumps stop within a day. Hospitals run on generators until fuel runs out, and then they stop too. Stay with me, because what comes next in this list is worse. Modern civilization does have some protection in place. Power companies monitor solar activity. Some grids have hardened transformers. But the honest truth is that most of the global grid was built before anyone understood this risk existed, and retrofitting an entire planet's electrical infrastructure costs more than most governments are willing to spend on a threat that has not happened in over a century and a half. Replacement transformers are custom built overseas, with waiting lists stretching well over a year, meaning a widespread failure could leave entire regions without power far longer than most assume possible. If you want to see the actual evidence, go to earthobservatory.nasa.gov. Search for Carrington Event Geomagnetic Storm. The satellite imagery of solar flare activity is there right now. You can see it yourself. This threat rarely comes up in mainstream conversation. And the reason is not mysterious once you think about it. There is no political appetite for telling a population that runs on electricity that its entire way of life depends on the unpredictable temper of a star 93 million miles away, and that nothing currently built could stop it. Acknowledging the scale of the vulnerability means admitting there is very little anyone can do about it right now, and that is not a comfortable message for anyone to deliver. Think about your phone battery, your refrigerator, the traffic lights on your drive home. Every single one of them depends on a grid that has never been tested against a storm this size in the modern era. Scientists say a storm of this magnitude is not a question of if, only when. And what happens next on this list would not wait politely for that grid to come back online. If the idea that prehistoric forces could erase modern civilization in hours fascinates you, subscribe to Prehistoric Legends right now. Every week I bring you the secrets history deliberately buried. Hit subscribe. It is free. And number 9 would hit even faster than this. Number 9, Cascadia Subduction Zone. Off the coast of the Pacific Northwest, there is a fault line 300 kilometers long that has not moved in over 300 years, and it is overdue. In 1700, it ruptured violently enough that a tsunami crossed the entire Pacific Ocean and struck the coast of Japan, where residents recorded an orphan wave, one with no earthquake of their own to explain it. They had no idea the ground had torn open an ocean away. When that rupture happened, the coastline of what is now Washington, Oregon, and Northern California dropped several feet in an instant. Ancient forests were drowned in salt water within minutes, their ghost stumps still visible today at low tide. Still standing where they died, bark still intact after more than 3 centuries underwater. The wave that followed reshaped the coastline permanently, burying entire river valleys under sediment carried in by the surge. There was no one there to call it a disaster. There was only silence, and drowned trees, and water where land used to be, and generations of indigenous oral history that would later describe the ground shaking and the sea rising to swallow the shore. Now picture that same fault line breaking today, under a coastline packed with over 10 million people. Seattle, Portland, and Vancouver would experience violent shaking for 4 to 6 minutes straight, which sounds short until you understand that most structures are only built to withstand seconds of that intensity. Bridges fail. Overpasses collapse. Fuel pipelines that supply the entire region rupture underground, and airports built on soft coastal soil see their runways buckle and crack before a single plane could take off to help. And this is before the wave even arrives. The tsunami, generated by a Cascadia rupture, would reach some coastal towns in as little as 15 minutes, faster than most emergency evacuation plans assume people can move. Entire coastal communities would be erased before rescue teams could even be dispatched, let alone reach the survivors stranded on whatever high ground remained. Emergency planners have quietly estimated that a full rupture could kill over 10,000 people and leave over 1 million displaced. And you need to hear what scientists found when they actually ran the numbers. The Pacific Northwest does have earthquake building codes and tsunami warning systems, but officials in the region have acknowledged that critical infrastructure, including bridges, fuel pipelines, and hospitals, is not built to survive a rupture of this size, and that recovery in some areas could take years, not weeks. Some emergency planning documents describe the aftermath simply as the worst disaster in the history of the region, noting that certain coastal towns may not be rebuilt at all, and that outside help may not reach isolated communities for weeks after every road and bridge connecting them has failed at once. If you want to see the actual evidence, go to earthquake.usgs.gov. Search for Cascadia Subduction Zone Rupture History. The seismic record of past ruptures is there right now. You can see it yourself. Why does this not dominate public conversation the way it should? Partly because the fault sits silently offshore, invisible and unfelt for centuries, and partly because acknowledging the true cost of preparing for it, in bridges rebuilt and pipelines rerouted, is a bill few governments want to present to their taxpayers before disaster forces the issue. If you live anywhere near that coastline, the ground beneath your home has already done this before, and it remembers. The geological clock on this fault has been ticking since 1700. Nobody can tell you the exact day it resets, only that it will. Number 8. Yellowstone Supervolcano. Beneath Yellowstone lies a chamber of molten rock large enough to bury an entire continent in ash, and it has erupted catastrophically 3 times in the last 2 million years. The last major eruption blasted so much material into the sky that ash fell across nearly the entire western half of what is now the United States, burying ancient rhinoceroses alive where they stood. An event so complete that their fossilized remains still lie exactly where they fell, entombed in the very ash that killed them. That ancient eruption reshaped the climate of an entire hemisphere. Sunlight dimmed for years. Ecosystems that took millennia to establish were smothered under meters of volcanic debris in a matter of days. Nothing that lived within hundreds of kilometers of the eruption survived the initial blast, and everything beyond that radius faced a slow, grinding climate collapse that unfolded over seasons and years. Rivers ran choked with ash for years afterward, and forests that had stood for centuries were flattened by pyroclastic surges before they ever caught fire. If Yellowstone erupted today, the immediate blast zone would destroy everything within a radius of roughly 100 kilometers within minutes. But the real catastrophe would unfold in the days that follow. Ash would fall across the entire central United States, collapsing roofs under its weight, grounding every aircraft in North American airspace, and choking engines, lungs, and water supplies simultaneously. Highways would become impassable under drifts of gray ash, and emergency vehicles themselves would stall as the fine particles clogged their engines within hours of the eruption beginning. Agricultural experts have estimated that ash fallout from a Yellowstone eruption could render the American Midwest the breadbasket of an entire continent, unable to produce crops for up to a decade. Global temperatures could drop by several degrees for years afterward, triggering crop failures far beyond North America, from wheat fields in Ukraine to rice paddies across Asia. Keep watching, because the next catastrophe on this list has already started. Emergency response plans for a Yellowstone eruption exist on paper, but officials who have studied the scenario admit privately that no plan currently accounts for feeding, housing, and evacuating tens of millions of people simultaneously while global agriculture collapses. There is no functioning blueprint for a disaster this size, because nothing in recorded human history has ever required one. Even national grain reserves, built to buffer a single bad harvest, hold only a fraction of what would be needed to carry a country through years of failed growing seasons. If you want to see the actual evidence, go to volcanoes.usgs.gov. Search for Yellowstone caldera monitoring. The current data on ground deformation and magma chamber activity is there right now, updated regularly by scientists who track it around the clock. You can see it yourself. This is rarely discussed honestly in public because the true implications, global famine, mass displacement, the collapse of food supply chains that feed billions, are simply too large for any single agency to plan around, and admitting there is no adequate plan is not something institutions like to say out loud. It is easier to fund monitoring equipment than to fund an honest public conversation about what happens if that equipment ever detects the eruption everyone hopes never comes. Every meal on your table today depends on a system of farmland that this single eruption could bury under ash within days. Scientists monitoring the caldera say it is not a matter of whether Yellowstone erupts again, only when and whether anyone will be given enough warning to matter. Number 7. Campi Flegrei Supervolcano. Beneath the Bay of Naples lies a volcanic system so vast that ancient Romans built entire cities inside its collapsed caldera without knowing it, calling the sulfurous, steaming ground the Fields of Fire, a place where the earth itself hissed and smoked between the vineyards. 2,000 years ago they walked across ground that was, and still is, sitting directly above one of the most dangerous volcanic systems on the planet, unaware the earth beneath their sandals was breathing. The eruption that formed this caldera thousands of years ago was catastrophic enough to alter climate patterns across the entire Mediterranean region. burying ancient settlements under layers of ash and pumice that archaeologists still uncover today. Entire communities from that era vanished from the historical record almost completely, their existence known only through what the ash preserved entire villages frozen mid-moment beneath the debris, much like the more famous city buried by Vesuvius centuries later. Today, Campi Flegrei sits directly beneath Naples, a city of nearly 1 million people, and the ground itself has been rising for years, a phenomenon geologists call bradyseism, where entire neighborhoods are lifted centimeters at a time by pressure building underneath, cracking apartment walls and buckling roads that residents have learned to simply repair and ignore. If this system erupted at scale, the first hours would bring pyroclastic flows moving at speeds too fast to outrun across the entire Bay Area, racing across the water toward Naples itself within minutes of the first blast. The scale of potential loss is almost unspeakable. Naples and the surrounding region hold close to 3 million people within the immediate danger zone. Evacuation plans exist, but they were designed decades ago for a much smaller population, and emergency officials have acknowledged that evacuating the current population in time would be logistically almost impossible, with narrow roads and a single-ring highway expected to carry a population the size of a small country away from a coastline with nowhere else to go. And nobody is talking about what happens when two of these hit at once. Italian authorities do monitor the area closely, and alert levels have been raised repeatedly in recent years. But scientists studying the caldera have stated plainly that current evacuation infrastructure, the roads, the ferries, the rail lines, could not move 3 million people out of the danger zone within the window of warning an eruption would likely provide. If you want to see the actual evidence, go to volcanoes.usgs.gov. Search for Campi Flegrei caldera unrest. The ground deformation data collected over the past several years is there right now, showing the same rising ground residents can feel for themselves every time a new crack appears in a wall. You can see it yourself. The reason this rarely reaches global headlines is uncomfortable but simple. Naming a specific eruption timeline would collapse property values, tourism, and daily life across an entire region long before any eruption actually occurred, and no government wants to be responsible for triggering that collapse over a probability, however serious. Entire local economies depend on residents and visitors not thinking too hard about the ground they are standing on. If you have ever dreamed of visiting Rome or Naples, or already have photographs from a trip there hanging on your wall, understand that both cities exist in the shadow of a system capable of ending them within hours. The ground beneath the Bay of Naples has already erupted with enough force to change a continent's climate once before, and the people living above it today have no memory of that event at all. It has never stopped rising since. Number 6. Laschamps magnetic reversal. 42,000 years ago, Earth's magnetic field did something it has never fully recovered from since. It weakened dramatically, wobbled, and briefly flipped, dropping to roughly 6% of its normal strength. For a period lasting centuries, the planet's protective shield against solar and cosmic radiation nearly disappeared. Early humans living through this period would have witnessed auroras dancing across skies far from the poles, a glowing warning with no name and no explanation, visible from latitudes where the sky had never lit up like that before and would not again for tens of thousands of years. During this collapse of the magnetic field, radiation levels at the surface rose sharply. Some researchers have connected this period to shifts in climate and even extinction events among large animal species, along with behavioral changes in early humans, including a possible increase in the use of protective ochre and cave shelter. The sky itself had become something to hide from, and evidence suggests entire populations shifted their movements to avoid the harshest exposure during those centuries. If a Laschamps level weakening happened today, the consequences would strike a civilization utterly dependent on the very technology that magnetic field protects. Satellites, the backbone of navigation, communication, and financial systems, would face radiation damage within days. Power grids around the world would experience surges similar to a solar storm, but sustained over months or years rather than hours. Airlines would be forced to reroute polar flights entirely, away from the radiation exposure concentrated near the weakened poles, disrupting global travel and shipping for the duration of the event. Unlike a single solar storm, a magnetic field collapse does not end after one bad day. It could persist for decades, exposing the surface to elevated radiation continuously, damaging crops, satellites, and possibly increasing cancer rates over time, a slow accumulating cost with no single moment anyone could point to as the disaster's beginning. Stay with me, because what comes next in this list is worse. Modern civilization has no meaningful defense against a weakening magnetic field. Satellites can be hardened somewhat against radiation, but replacing an entire orbital communication network while the field remains weak would be attempting repairs during the exact conditions causing the damage in the first place, an endless cycle of launching replacements only to watch radiation degrade them faster than they can be deployed. If you want to see the actual evidence, go to NCBI, nlm.nih.gov. Search for Laschamps excursion geomagnetic field. The published research on this ancient magnetic collapse is there right now, drawn from lava flows and sediment cores that recorded the field's exact strength at the time. You can see it yourself. This threat receives little public attention because, unlike an earthquake or an eruption, a magnetic field weakening has no single dramatic moment, no headline event to point a camera at. It unfolds slowly enough that institutions can avoid discussing the compounding decade-long consequences, because there is no single day to blame it on, no press conference forced by a sudden disaster, just a slow drift in readings that most people will never see reported anywhere. Every satellite that tells your phone exactly where you are right now depends on a magnetic shield that has failed completely before, and geologists confirm it is already showing signs of gradual weakening again today. Nobody living through the last reversal understood what was happening to the sky above them, and they had nothing built that radiation could destroy. We would understand exactly what was happening to us, and that might be worse. If you have not subscribed yet, this is the moment. You are halfway through. Prehistoric Legends uploads every week. Hit subscribe and the bell icon so the next video finds you. Because the top 4 catastrophes on this list would not just erase civilization, they would make sure nothing could ever be rebuilt. Number 5. The Storegga Submarine Landslide. 8,000 years ago, off the coast of Norway, an enormous section of the continental shelf gave way all at once, sliding into the deep ocean in one of the largest submarine landslides ever recorded, a slab of seabed, the size of a small country, collapsing into the depths in a matter of minutes. The displaced water rose into a wave that crossed the North Sea in a matter of hours, striking the coastline of what is now Scotland, with a wall of water tens of meters high. The communities living along that coastline at the time had no warning system, no understanding of what was building beneath the waves offshore. Archaeological evidence shows the waves scoured low-lying settlements completely, leaving sediment deposits that modern researchers can still trace along the Scottish coast today, a physical scar left by a single afternoon of destruction. If the same slope failed again today, the first hours would unfold with terrifying speed. Modern coastal cities across the North Sea, including parts of the United Kingdom, Norway, Denmark, and the Netherlands, would have only hours of warning, if any warning system detected the landslide at all before the wave made landfall. Low-lying regions of the Netherlands, already below sea level and protected by engineered barriers, would face waves those barriers were never designed to withstand, sending seawater surging past flood defenses built to handle storms. Not a wall of water generated by a collapsing seabed hundreds of kilometers away. The scale of destruction would be almost impossible to contain. Coastal cities housing tens of millions of people sit directly in the path such a wave would take. Emergency planners have noted that current tsunami warning systems for the North Sea are far less developed than those in the Pacific, largely because a repeat event has been considered unlikely on any human timescale, and you need to hear what scientists found when they actually ran the numbers. The unstable slope responsible for the original Storegga slide is still there today, still sitting on the seabed, and researchers have identified similar unstable formations nearby. Current monitoring of these underwater slopes is minimal compared to monitoring on land, largely because underwater geological hazards receive a fraction of the research funding that earthquakes and volcanoes attract, leaving a genuine blind spot in a region most people assume is among the best monitored on Earth. If you want to see the actual evidence, go to ncei.noaa.gov. Search for Storegga slide tsunami deposits. The sediment core data confirming the ancient wave's path is there right now, pulled directly from the seabed cores researchers have studied for decades. You can see it yourself. This threat is rarely discussed publicly because underwater landslides do not generate the same fear or funding as volcanoes and earthquakes, despite producing waves just as devastating. Acknowledging the risk would mean admitting that some of the most densely populated coastlines in Europe have almost no early warning infrastructure for this specific threat. If you live along the coastline of Northern Europe or have ever booked a holiday to its beaches, the seabed beneath those waters has already done this once, without warning. And it did not ask permission the first time either. The slope is still there, the water is still deep, and nobody currently monitoring it can tell you exactly when it will move again, only that the last time it did, an entire coastline had no idea what was coming until the wave was already on top of it. Number 4. Chicxulub scale asteroid. 66 million years ago, an object roughly 10 kilometers wide struck the Earth off the coast of what is now Mexico, with a force greater than billions of nuclear weapons combined. The impact vaporized instantly everything within hundreds of kilometers, triggered earthquakes that shook the entire planet, ignited wildfires across entire continents, and threw enough debris into the atmosphere to block sunlight globally for months. Within that darkness, roughly 3/4 of all species on Earth, including every non-avian dinosaur, went extinct. An ending so abrupt that fossil layers show thriving ecosystems on one side of a thin line of ash and almost nothing on the other. The world before that impact was thriving, diverse, and utterly unprepared. Within hours of the strike, tsunamis crossed entire oceans, scouring coastlines thousands of kilometers from the point of impact. Within months, a global winter descended, collapsing food chains from the bottom up as plants died first, then the animals that depended on them, then the predators that depended on those animals in turn. It took the planet millions of years to recover the biodiversity lost in that single afternoon, and some ecological niches never returned to what they had been before. Modern detection systems can now identify large asteroids years or even decades before a potential impact, which sounds reassuring until you understand the actual constraint. Even with 6 months of confirmed warning, the logistics of evacuating major coastal cities, relocating critical infrastructure, and protecting food supplies on that timeline simply do not exist as a functioning plan anywhere on Earth today. 6 months is enough time to argue about who should move first, and barely enough time to move anyone at all. Modeling this scenario today produces staggering numbers. An impact of this scale would generate megatsunamis capable of devastating every coastline within thousands of kilometers, block sunlight enough to collapse agriculture globally for years, and could kill a majority of the human population, not through the impact itself, but through the famine and societal collapse that follows in the months and years after. Cities untouched by the initial blast would still watch their supply chains and food systems unravel completely. Do not skip ahead. What comes next changes everything about how you see this. Space agencies do track near-Earth objects, and deflection technology has been tested in recent years with some success. But officials involved in planetary defense have acknowledged that current deflection capability only works effectively if the threat is identified with many years of lead time, not months, and an object discovered late would leave humanity with detection but no meaningful response, a countdown with no working break attached to it. If you want to see the actual evidence, go to jpl.nasa.gov. Search for Near-Earth Object Tracking Chicxulub Impact. The impact crater data and current detection catalog are there right now, updated as new objects are discovered and their orbits refined. You can see it yourself. This scenario receives less public attention than it deserves because it is a threat with no clear timeline. Easy to acknowledge in the abstract and easy to deprioritize in annual budgets, right up until the moment detection systems find something moving toward us with insufficient time left to act. Every meal you eat, every crop grown anywhere on the planet, depends on a level of sunlight this single event proved can be blocked for years at a time. The dinosaurs had no warning at all. We would have 6 months. The question this list forces you to ask is whether 6 months would be enough to matter. Number 3, Toba Supervolcano. 74,000 years ago, a supervolcano named Toba erupted with such force that it ejected an estimated 2,800 cubic kilometers of material into the atmosphere, the largest volcanic eruption in the last 2 million years. An event so massive that its ash has been found preserved in ocean sediment on the opposite side of the planet. Ash fell across the entire Indian subcontinent in a layer meters thick, and the atmospheric fallout triggered a volcanic winter that plunged global temperatures for years afterward. Genetic evidence suggests that early human populations were reduced dramatically in the aftermath of this eruption, with some researchers estimating the surviving global population may have fallen to as few as several thousand individuals scattered across isolated pockets of habitable land. Our species came astonishingly close to disappearing entirely because of a single eruption. A genetic bottleneck still visible in human DNA today, tens of thousands of years later, a signature written permanently into every person alive. If an eruption of Toba's scale happened today, the immediate blast zone would be obliterated within minutes, but the true catastrophe would unfold globally over the following years. Ash and sulfur aerosols would circle the planet, blocking sunlight and dropping global temperatures by several degrees for years, an event modern agriculture, entirely dependent on stable growing seasons, has never been tested against, since no harvest in recorded history has faced a sky dim this severely for this long. The scale of modern vulnerability is staggering precisely because global population and food supply chains are so interconnected. A volcanic winter today would not just affect the region near the eruption. It would collapse harvests on every continent simultaneously, triggering famine among a global population of billions who have never experienced a multi-year agricultural failure. A population that has never known a growing season that simply failed to arrive at all. The next entry makes this one look survivable. There is currently no supervolcano eruption of this magnitude that any government has a realistic plan to survive without massive loss of life. Some research into geoengineering and emergency agricultural stockpiling exists, but experts studying the scenario have noted that current global food reserves would last only a matter of months, not the years such an eruption would require, leaving a gap between what exists and what would actually be needed that nobody has closed. If you want to see the actual evidence, go to ncbi.nlm.nih.gov. Search for Toba catastrophe genetic bottleneck. The published genetic and ash layer research is there right now, including sediment cores drilled thousands of kilometers from the eruption site that still show the ash layer clearly today. You can see it yourself. This threat rarely enters public conversation because supervolcanoes erupt on timescales measured in tens of thousands of years, making them feel abstract and distant. Even though geologists confirm several systems capable of eruptions this size remain active on Earth right now, quietly building pressure in places most people have never heard of. Whatever you had planned to eat this week depends on a growing season this exact event proved capable of erasing for years at a time, a fact almost nobody thinks about while filling their plate at dinner tonight. Our species has already survived this once, reduced to a population smaller than most modern cities, scattered across a handful of surviving refuges. Whether we could survive it again, with billions more mouths to feed and far more fragile supply chains to depend on, is a question nobody currently has a confident answer to. Number 2. Global ocean circulation collapse. The Atlantic Ocean contains a vast system of currents that transports warm water northward, keeping Western Europe far milder than its latitude would otherwise allow, the reason London stays milder in winter than cities at similar latitude across the ocean. This circulation has weakened and reorganized dramatically in Earth's past, most notably at the end of the last ice age, when a sudden influx of fresh water disrupted the system and plunged the northern hemisphere back into near glacial conditions within just a few decades. That ancient collapse, sometimes described alongside the younger Dryas cooling period, reshaped ecosystems across an entire hemisphere in what geologists consider an almost instantaneous shift by climate standards. Regions that had been warming for thousands of years plunged back into ice age conditions in a span of time within a single human lifetime. A speed of change that still stuns researchers who study the sediment and ice core records today, records that show glaciers re-advancing and forests dying back within a span most people would associate with a single generation, not a geological era. Today, scientific monitoring has detected significant slowing in this same Atlantic circulation system, driven by melting ice sheets adding fresh water to the North Atlantic. If this circulation collapsed fully, Western Europe could face a dramatic cooling of several degrees within a matter of decades, even as the rest of the planet continues warming overall. An almost paradoxical outcome most of the public has never been told to expect. The consequences would ripple far beyond temperature alone. Agricultural regions across northern Europe, currently responsible for feeding hundreds of millions of people, would face shortened growing seasons and disrupted weather patterns. Shifts in this circulation could also alter monsoon patterns in Africa and Asia, threatening food security for a significant portion of the entire human population. Regions on the opposite side of the planet from the Atlantic itself, tied together by a single current system few people realize connects them at all. Stay with me. Because what comes next in this list is worse. Climate models do account for this circulation system, but researchers studying it have acknowledged significant uncertainty about exactly when or how fast a full collapse could occur, ranging from decades to potentially far sooner than previously assumed. There is currently no engineering solution capable of restarting an ocean circulation system at planetary scale, and none currently being seriously developed, because the scale of intervention required is simply beyond what any nation could fund or build alone. If you want to see the actual evidence, go to usgs.gov. Search for Atlantic Meridional Overturning Circulation Collapse. The current oceanographic monitoring data is there right now, gathered from buoys and instruments tracking the current strength year after year. You can see it yourself. This scenario receives less attention than dramatic single-day disasters because it unfolds over years and decades rather than hours, making it difficult to communicate with the same urgency as an earthquake or an eruption, even though the agricultural and economic consequences could ultimately affect more people than either. The mild winters much of Europe has always taken for granted exist entirely because of a current system that has failed abruptly before, and instruments are already showing it slowing down again right now, quietly, in data most people will never see published anywhere. The last time this system failed, it happened faster than anyone studying the ice cores expected, catching an entire hemisphere off guard with no warning at all. The next entry on this list asks what happens when disasters like this stop happening one at a time. Number 1, simultaneous multi-system failure. Every catastrophe on this list has one thing in common that almost never gets discussed. Each one has been studied, modeled, and planned around as an isolated event, a single disaster striking a world otherwise functioning normally. But the geological record shows that Earth's worst periods of upheaval rarely involve just one system failing. They involve several failing within the same narrow window of time, compounding each other faster than any recovery effort can respond, each disaster removing the exact resources that would have been needed to survive the next one. Ancient climate records show periods where volcanic eruptions, magnetic field weakening, and abrupt ocean circulation shifts overlapped within centuries or even decades of each other, a blink of an eye geologically. Ecosystems already destabilized by one shock had no chance to recover before the next one struck, and mass extinction events across Earth's history frequently show this exact layered pattern of overlapping catastrophes rather than a single clean cause, a pattern paleontologists have found again and again once they started looking for it, instead of assuming one disaster at a time. If two of the catastrophes on this list struck within months of each other today, the results would overwhelm every emergency system built to handle them individually. A solar storm crippling the power grid while emergency services were still responding to a major earthquake would leave hospitals without power precisely when they were most needed. A volcanic winter beginning while ocean circulation was already disrupting agricultural regions would compound food shortages faster than any stockpile could offset, turning two survivable disasters into one that no country currently has the resources to absorb. Modern emergency planning is built almost entirely around single disaster scenarios. Government response frameworks assume one crisis at a time, with resources from unaffected regions flowing in to help. But a compounding scenario, two or more of these systems failing together, would mean every region is simultaneously overwhelmed, with no unaffected reserves left anywhere to draw from. It is not one collapse. It would not resolve into recovery, because recovery itself depends on borrowed strength from parts of the world that a compounding disaster leaves with nothing left to lend. The honest, uncomfortable truth is that no government on Earth has built a response plan for compounding, simultaneous catastrophe on this scale, because doing so would require acknowledging that modern civilization's entire safety net assumes disasters arrive one at a time, an assumption the geological record does not support, and has never supported. Not once. Across the entire history of this planet. If you want to see the actual evidence, go to usgs.gov, search for Compound Geological Hazard Risk Assessment. The research modeling overlapping natural disaster scenarios is there right now, a small but growing body of work that most emergency planning has not yet caught up with. You can see it yourself. This scenario is almost never discussed publicly because there is no single agency responsible for planning around multiple overlapping disaster types at once, and admitting that gap would mean admitting that the entire framework of modern disaster response was built on an assumption the past has already disproven more than once. Whatever single disaster crossed your mind while watching this list, understand that history's worst chapters were rarely written by just one of them acting alone. Every catastrophe you just heard about has already happened before, separately, each one leaving its own mark in the rock and ice for anyone willing to look. The only question left is how much time remains before more than one of them happens again. Together, CTA3, every catastrophe in this video has happened before. The geological evidence exists. The ice cores confirm it. The rock layers prove it. Subscribe to Prehistoric Legends so you do not miss what is coming next. The link is on your screen right now.